It says here that Mr. Taylor has decided to get into the transportation business. He wants to buy a motor vehicle to take students and teachers to school. The school, the schools are located in Baker Town. He has decided to buy a bus or a car. So we're going to be buying a bus or a car here. Let us see what the objectives are. So here it is. It says that the students and teachers live in Prime Estate. So everybody live in Prime Estate, which is located in Baker Town. Help Mr. Taylor to one, determine the actual distance between different locations. Two, calculate the actual number of trips that a bus and a car make on a given day. Three, calculate the amount of money that could be made daily from each vehicle. And four, recommend which of the two vehicles he should buy. Okay, let us get into the questions. The first question here, part one, we're looking at Baker Town. Look at what's going on. The diagram below represents places located in Baker's Town, or in Baker Town, should say. So we're looking at the high school, then we're seeing a primary school, and we're seeing prime estate. So those are the three things that are there. Now let's go to the question. So the question says, the table shows the units on a map of Bakertown and their actual distance. Okay, for every unit, this is important, given on the map, it's actually 100 meters. So every unit we see, it's 100 meters. All right, so its actual distance is 100 meters. So we want to make note of that. Now, here it is. Examine table one carefully. Then complete it by writing the appropriate unit or meters in the blank spaces. Remember, one unit represents 100 meters. All right, let's get into it. Now, as you could see, they did they led here by showing that one unit is 100 meters. You're seeing that. Two is 200 meters. So definitely, if you're seeing 300, then 300 divided by 100, and you're gonna get three. So it's 3 units for that. And then for 6 units, it's gonna be 6 times 100. And that is gonna give you a total of 600 meters. All right. And then for 1,000 meters, if you take that 1,000 and divide it by 100, it's going to take you back to how many units? So it's 10 units right there. And as you could see, 20 for 2,000, it's there, and 30 would be for 3,000 because you're multiplying. This 30 will be multiplied by 100, which means you're adding 2 zeros to it. So it's going to give you 3,000 meters right there. So as you could see, we're representing 1 to 100. That's the ratio. That's the movements between each unit to the number of meters. You simply multiply by 100 and you get it. Okay. All right. So that's question one. So we're getting a feel of what's going on here. Now let's take a look at diagram one. Diagram one shows the map of Bakertown. There is also a key to help you to identify the symbols on the map. Okay, so let's take a look at the key here. All right, so here they're telling us that when you look at these square boxes, that's 1 unit. This is also 1 unit. And this is what the road is like. All right, so we have the key. Let's go back to look. So you take a look. Let me zoom out a little bit so that you could see better. So we're looking at Prime Estate. We're looking at the entrance to Prime Estate right here. Okay. All right. So that's important to what we're doing. We're looking at the high school and we're seeing the entrances also for the high school and the primary school and so on. So we're seeing those, all right? All right, so we're looking at the road and so on. So let us now see what it is that they want us to do outside of that. All right, let's get into it some more. All right, so prime estate. Let me see if there was a question here. All right, no. So we did question one. All right, so question two. All right, let's get to question two right now. So it says here, um, question two. For question 2A, 2B, and 2C, each row has a statement made about the map in diagram one. So they made statements here. We want to place a tick under the appropriate heading indicating whether the statement is true or false. We are being reminded that 1,000 meters is 1 kilometer. All right, so we're reminded of that. Now let's take a look. So we're going to tick whether or not which one is true or false. So statement one, it says the primary school and the high school are both located on Main Street. So we're going to look on the road if we see Main Street. And then we're going to look if the primary school and the high school are both on that street. So you got to be reading. Let's take a look. Main Street. I found it. Now here is Main Street. Here is Main Street. This is Main Street here, right? So definitely the primary school and the high school are on Main Street. Let me mark it up one more time. This is Main Street here. This is Main Street right here. That's it. So here is the primary and there is the high school. So definitely they are both on Main Street. So yes, it's true. Primary school and the high school are both on Main Street. Let's put a tick in that. That is true. Now let's go to the B part. It says, Mr. Taylor will drive less than 1,000 meters between the entrance of the high school and the entrance of the primary school. Okay, so they're saying that he's going to drive less than 10 units because remember now, if you take this meters and you divide it by 100, you're going to get 10. So basically they're saying that there's less than 10 units between the primary school and the high school. Let us check that out. Let's check that out. So we're going to go to the entrance. Here is the entrance of the high school. And we're going to count all the way up to the entrance of the primary. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we arrive. So it's not less than it. All right? It's not less. So we actually have 10 units between them. So it's not less. So that statement is not true. Okay? So let's look back at what they're asking. They're saying that he drove less than, they're saying that he drove less than 1,000 meters, which would have been 10 units. No, that is false. Didn't drive less than it. Okay? All right. Now, so we're looking at part C here. If Mr. Taylor uses English Road to go from the prime estate entrance to the high school entrance, all right, he will drive at least, and when we say at least, so this is, watch this now, this is 1.6 km. If you want to turn this into meters, you take your 1.6 and you multiply it by 1,000, and you're going to get 1,600, right? This is 1,600 meters. And then if you want to know units, like how many units this is, what if you're counting the units? All you got to do is to divide by 100, and it's going to tell you that 16 units. So you could think of 16 units, or you could think of 1,600 meters. So we're checking. We're going to check from Prime Estate along English Road to see if we get at least 16 of these. So remember I said at least, so it is 16 or more, okay? So let us check. Where is English Road? So identified English Road is on this side. So we're moving from here. Then take a look at our prime estate. Let's minimize this a little bit. So yes. So where we're moving from now, we're moving from the entrance of prime estate, which is right here. That's the entrance of prime estate right there. And then we're going to check to see, so from here, how many units we're getting. So on the road, this is 1 unit, 2 units, 3 units, 4 units. You come out here, 5 units, 6 units, 7, 8, 9, 10, 11, 12, 13, 14. And then you're going to have to drop up 15, then 16 before you reach. And if you put in the fact that the car will turn, these are more, these are actually more if you're thinking about driving on the road. So at least 16 already. All right. So definitely this statement is true. He's going to do 16 or more of those units, which would have mean 1,600 meters. And if you put that in kilometers, 1.6. So definitely, yes, he's going to do at least that. It could be more. So we know that much. So it is true. So that statement is true. So let us keep going to the second part. So for the second part of the question, it says, part two, number of trips. So we're focusing on the number of trips now. Let us take a look. It says diagram 2 shows on average the number of trips made with a full loads by each vehicle, car, and bus in a day. Okay, so this is the full load and the total number of trips on average for both bus and car. So let's take a look. Now read again. It says each trip is made between, okay, so the trips are made between prime estate and the primary school. So this is what we're focusing on. So these trips between prime estate and the primary school. A full load is when all the seats in the vehicle are occupied by passengers. So a full load is when everything is full out and everybody's seated. All right, we got that. Now let us look on the diagram. So let's look at the heading. The heading says the bar graph showing the number of full loads made by two vehicles at different time period in a day. So at different time period, you're seeing between 6 to 8 in the morning, 8 to 10, 2 to 4, and 4 to 6. All right. So sometimes what you could do is I like to put on the numbers on top so you could quickly see it. So this is 6. We're talking about the number of trips made, right, for the full load. So that is 6 trips. This one did 2 here. This is 3. So let's put on some numbers. Come on. This is 1, 2, then this is 3, 4, this is 5, and 7. So I want to put on those numbers. So this is 3, this is 1. I'm just putting on the number of trips so you could see it. This is 6 again. This is actually 2. Okay. And this is a 5 here, and this is 1. So we're definitely looking at the numbers because the numbers, they do help as you navigate. And remember now, look at the color code. The blue is for car and the yellow is for bus. So the blue is for the car and the yellow is for the bus. You want to make sure that you're seeing, you're understanding what's going on. So we have that information. Let's now look at the question that they want to ask. So the question says, question 3, it says 3A, based on the graph, right? What is the total number of trips made with a full load by the car and the bus in a day between primary state to the primary school? So all you're going to do is to add up these numbers for each. The blue is for the car and the yellow is for the bus. So we're going to take the numbers down. So we're taking down 6 plus 3 plus 6 plus 5. So that is for the bus. That's for the car, I should say. 6 plus 3. So for the car, we're dealing with 6 plus 3 plus 6 plus 5. Then I'm going to minimize so that we could see. Let me zoom out so we could look. Everybody could see 6, 3, 6, and 5, definitely. So if you should add these up, you want to make sure you're not making any errors. Come on. All right. So you add those up. 6 plus 3, that's 9. Plus 6, and that's 15. Plus 5, and that's going to give us about 20. So this is about 20 in total. Okay. So we have 20 in total. We're talking about the number of trips for this. For the bus is in yellow. So there is a 2, there is a 1, there is a 2, there is a 1. So we're seeing 2, 1, right? 2, 1. All right. So 2 for this is 6 trips. So we have 20 trips being made here by the car, and then we have 6 trips being made by the bus. We are taking note of that. All right. So there we go. We're seeing that. We'll look at it, make sure that we didn't make any error, look back, double check, and then we keep going. Our numbers look good. All right, so those are the number of trips made by cars and by the bus as we go through. So now let us see what else they want from us. All right, what else they want. Now it says here a full load for a car is when 4 passengers are seated. The ratio of the number of teachers to the number of students traveling in the car has when it's fully loaded is 1 to 3. So for every one teacher, it's 3 students. So T is for teachers and S is for students. So you could see the 1 to 3 right here. You're seeing that, which will be a total of 4 passengers, right? That's what we're thinking of. So you could see there, they work this out for us. So they're leading us into where we're going, all right? Now let's take a look at what they want, the bus, all right? So we want to work out what's for the bus. It says a full um, load for a bus is when 14 passengers are seated. Now, the ratio of the number of teachers to the number of students traveling in a bus that has a full load is 1 to 6. For every one teacher, then it's going to be 6 students. It says, what is the total number of teachers and students traveling in the bus that has a full load? Okay, there it is. It says, remember to use the ratio given above. Now it says, write your response on the seats. Well, we were told it's 14 already, but we're going to make sure that we fill them out in terms of T for students, T for teachers, and S for students on each seat. All right. So on each seat in the bus below, we're going to write this, we're going to write that. Okay. When then in the box provided, fill in the total number of teachers and students. Okay, so let us say I put the teachers in the front. So I have my teachers here and I have another teachers here. So for every teacher, I'm gonna have 6 students. So that's for the first teacher. And for the second teacher, so we actually have 2 teachers and 14, 2 teachers and 12 students. So the number of teachers, 2, and then the number of students would be 12, and when you add them, you get 14. So we're talking about 2 to 12 or 1 to 6, same idea, okay? So there it is, it's filled out. So the bus is full, and let's see what the question 4 is about. Question 4 says, what is the total number of passengers, right? Which would have been teachers and students that would have traveled by the car for an entire day. Now you got to go back, right? How many trips did this car made? How many teachers are on it? So we're going to go back to question 3A. We're going to look back at the diagram to help if you want to show the working. So let's go back to 3A, okay? Now, here is 3, here it is. We're talking, so that's it. But let's take a look at this information here. The car, we're talking about the car actually made 20 trips. If you want to make sure, look back at it. 6 plus 3, 9 plus 6, that's 15 plus 5, 20. The blue is for the car, blue. So we had 20 trips fully loaded, and it's only 4 persons in it. All right, so let's take a look now. So we had 20 trips. Let's go back to the question. Teachers, for every one of those trips is only 1 teacher. Remember now, 20 trips. That's what we had with the car. And in each trip, we have 1 teacher. And then you have 3 students. You can work this out, right? 1 teacher, because it's 1 to 3. So we're talking about, watch this now, show you working, right? Watch this. So it's going to be 1, right, times 20, because we had 20 trips overall. So that would have been 20 teachers For the students, we actually had 3 students in every trip, 20 trips. So we had 60. When you add all of that, it's 20 teachers plus 60 students. We carried 80 persons, passengers, you're talking overall. Okay. So we had 80 well split up right there. So we have that for the car. Okay. Now, again, let's go back to see the bus because you can't make any errors. So it's good to scroll back and forth. Nothing is wrong with that, just to make sure. We had 6 trips for the bus. Look, 2, 1, 2, 1 again. So that's 6. So we're gonna see. I think they're gonna let us work out that. So let's go back down. Right. All right. Now the question says, what is the total number of passengers, teachers, and students that would have traveled by bus on a given day? Use the response in 3A and 3B to help. Again, you're talking about having only 6 trips. All right, we did 6 trips with the bus. And then there's a ratio where we're doing 1 to 6. Okay, 1 to 6. But based on what we got, we actually had 2 teachers and 12, all right, students. So teachers and students making a total of 14. So we want to relax when we're going to work this out. So every time we have a full bus load, 2 teachers are on it, 12 students are on it. So let's work this out. We're talking about 6 trips times 2, because on every trip we only have 2 teachers, so that's 12 teachers coming out. We still have that 6th trip, and then we actually have 12 students. So you want to make sure that you're not erroring here, right? So this is going to give us 6, 12, 72, right? So now you want to add everything up together. You're talking about 12, 72, and you want to add this up. This is 4, right? So we had 84 passengers, right? We're seeing a little difference between the number for the car as well as in relation to the bus. But we're going to check this out, how the money part works, all right? So we actually have 84 passengers overall here. Let's get into it. All right, let's go. Now it says, based on your response, correctly complete the sentence given by writing bus or by car on the line below. On average, the dash takes more passenger on a given day. The bus, on average, the bus takes more passenger on a given day than the car. The bus takes more. You could see we have 84 passengers here for the bus, but we only had 80 for the car. So we gotta be thinking, right? So the bus takes more than the car. All right, let's keep going. We're getting there, almost done. It says part 3, amount of money made. Now, here's a question. Question 5. It says the fare that Mr. Taylor will collect for each teacher and for each student is given below. So here is it. The teachers are paying per kilometers, $6.50 per kilometers. Students are paying a flat rate of 96.65 flat rate. And flat rate would mean that it doesn't matter the distance that they're traveling. It's going to be the same 96.65 that they will be paying as students. Okay. Now, so that's good information there. All right. So let us see what's going on. The distance from the entrance of primary state to the entrance of the primary school is 30 units. So we got this. This is 30 units right there. All right. All right. So 30 units. All right. So we have that. All right. I remember with this 30 units, we could turn it out into, you know, meters and kilometers and so on. We're going to talk about that. All right. On the bus, it's about this diagram one. Now it says calculate the fare for travel from primary state to the primary school for one teacher. This is just one teacher. One. Be careful. One. So you're working in the space. Remember though, first thing I want to do is they want to know this, that giving us kilometers here. So I'm going to take my 30 units and I'm going to multiply it by 100. And it's going to tell me that we travel 3,000 meters. And that's from the beginning. That's how we work this out. But then we do know that if I take my 3,000 kilometers, if I divide it by 1,000, it's going to give me 3 kilometers. So if you travel from primary state to the primary school, you would have traveled 3 kilometers. Now, for a teacher, every kilometer is 65. So watch this now. So we're talking about the total fare for one teacher. So the total fare for a teacher is to take that 64.5 and you're going to multiply that by 3. Because remember, every kilometer the teacher traveled, it is $64.50. $64.50. So you multiply that by 3. And then you definitely realize that you're getting $193.50. So the teacher would have paid. So for this trip, watch this again, calculate the fare for travel from primary state to the prime for one teacher. So this one teacher would have paid $193, right? That's what the teacher would have paid, $193. All right, no problem. 193, let's keep that. Next, right here, we've got to pay attention. So let's take a look. Look, this is 193.50. That's what you'll get when you work out the regular stuff, right? But there is another little piece of information coming, and it says here, Part B says, but before we read it, it says fare are rounded to the nearest 100. So they're telling us to do that now, just for Part B. Now, on the line below, write the fare for one teacher to the nearest 100, all right, dollar that you calculated in A. Remember, in A, we get 193.50. Now, if to the nearest 100, you're going to underline this, and then you look next door. This is a 9. So if this is a 9, this part goes up to 2. So it's actually $200. If you're going to round off, you're going to round up because we're rounding to the nearest 100. So 190 something will be rounded up to $200. Basically, the teacher will be paid $200 to go, right? Now, for fare for one student, it's $96.60. Now, on the line below, we want to write the fare for one student to the nearest $100. So it's nearest 100. So look, 96.65, okay? We are saying here, this is 96. This is not even 100 yet. So the 100 spot would be a 0 here, right? But when you look next door, this is a 9. That means this spot goes up by 1. So it becomes $100. So it's rounded off to $100. So a student basically paying a flat rate of 100, while a teacher will be basically paying 200 based on calculations and everything that we have there. All right, so let's go. Now let's do this. It says, based on your response, all right, on question 4, 5B, 5C. Let me look back. I see this is 5. I think we just did 5B and C. All right. Where is question 4? Question 4 has to do with, oh, okay, probably looking at 80 for the bus and 84 for the 84 for the bus and 80 for the car. Okay. All right, let's see what they want. Let's see what they want. Let's go. It says here, what is the total amount of money that Mr. Taylor will make on an entire day with each? Okay, now watch this. For the car, we actually had 80 passengers. And for these 80 passengers, we actually had 20 teachers. So we actually had 20, we had 20 teachers. They're paying $200. So 20 times 200, that's about 4,000. For the students, we had 60 of them times their fee, which is $100. Then this is 6. When you add this up, put this together, it's 10,000. Okay, so it's $10,000 that we're dealing with right there, right? So we're dealing with $10,000. All right. Now for the bus, we had teachers. We only had 12 teachers. And remember, they're paying $200. So you want to work that out. That's about 2,400. For the students, we actually had 72 of them, and they're paying $100 each. That's 7,200. We want to add this up. So we're adding up our 24 plus our 7,200, and we're getting some $9,600 here for this one. All right, we have 9,600 for this. Now, let's get at it. Let's see what's going on here. All right, I think, let me just look, show you working. So we just want to calculate. Okay, so you see the car is winning now. You can see what's going on right here. You can see what's going on. The car is making more money right now, right? A little bit more money. Car is doing that. Let's go. Let's see what's going on. So it says here, based on your response throughout the task, which vehicle Mr. Taylor should Mr. Taylor buy, the car or the bus? Use your calculations if needed to do it. Oh, we're at the end. All right. All right. So basically, you could just write it back because we already worked it out. So for an entire day, now we're talking about the car made 10,000. The bus made 9,600. Now here's the thing. So it says use your calculation. We have the calculations. There it is. All right. All right. So now here are the things. In the space provided, explain why you would have recommended the car or the bus. Da da da. Use the calculation. Okay, good. So let's answer. So we're gonna answer the question. So here's the question: which vehicle should? So we're gonna say, Mr. Taylor should buy the car because he will make $400 more each day. You can say this and you're good. And if you want to show, you could show that 10,000 minus 9,600 would show that $400 that you'll be making by, because this would have been for the car and this is for the bus. So you could see that it's better to buy the car because you're going to make more money each day on any given day. Well, so we're taking the car right there. Thank you for watching Daily Maths Concepts. Make sure you like this video, share it, subscribe to the channel. See you next time. Bye-bye.